All right, section 8.7 is on improper integrals. So here's an example of an improper integral. Integral from 0 to infinity of e to the negative x dx. So what this is saying is take the area under the curve from 0, so start at 0, and go all the way off to infinity. So start at 0 and find all this area. Go on forever. So this section has an infinitely long base. Now you might say, well, this area has to be infinite because this shape is infinitely long. Well, not necessarily. This area here, it could be a finite number. So if you keep adding on a little more area, a little more area, a little more area, well, your area, the area that you're adding on could be getting smaller and smaller and smaller. You might be adding on smaller and smaller chunks of area. If that area gets small really, really fast, starts to get small really fast, well, then this area might actually all add up to a finite number. So the idea behind computing this integral is as follows. So what we're going to do is we're going to take more and more area under the curve and see what happens. So you got your function here, e to the negative x. So what we're going to do is we're going to take the area out to some number b. So we're going to take a bunch of area and we're going to ask, well, what happened? So we're going to take the area out to b. See, well, how big is that number? How much is that area? And then what we're going to do is we're going to push b out further. And we're going to say, okay, let's say maybe b is way out here. Let's take all this area out to b and see what happens. And then we'll just keep pushing b further and further out. And we'll see, okay, as we calculate more and more area, is the amount of area we're getting approaching a number? So eventually, so we're going to take b very, very far out and see what happens. As b gets bigger and bigger and bigger, is the amount of area we're finding approaching a number. In other words, we're doing a limit. So if we want to do this integral from 0 to infinity of e to the negative x, what we're going to do is we're going to take the limit as b goes to infinity of the integrals of 0 to b of e to the negative x dx. So this set of mathematical symbols describes this idea. Take the limit as b goes to infinity of the top bound means we're going to take the limit, we're going to find the limit of the area as we take more and more area. Okay, so we know how to compute an integral like this. We know how to compute an integral like that. We find an antiderivative. We plug in the top bound, we plug in the bottom bound, and subtract. So an antiderivative of e to the negative x is negative e to the negative x. You want to be able to guess and check on that one. We're supposed to plug in b, plug in 0, and subtract. So we're trying to find the limit as b goes to infinity of negative e to the negative b minus negative e to the 0. So minus and negative is plus. So this really is just plus 1. So we're trying to find the limit as b goes to infinity of negative e to the negative b. All right. Well, e to the negative b. That's the same thing as 1 over e to the b. So this is really 1 over e to the negative 1 over e to the b plus 1. So as b gets bigger and bigger, e to the b gets bigger and bigger. Negative 1 divided by gigantic numbers gives you tiny numbers. Okay, so that limit there is 0. 0 plus 1, you get 1. Okay, so it turns out we did get a finite number. This area under the curve, it turns out this whole area under the curve is 1. So we say this integral is convergent. If an integral is convergent, that means that when you take the integral, you get a finite number.